All right. Do you want to give some starting info, or should I just kick it off?
Yeah, you can take it ahead. Yeah, sure.
All right. Hi everyone, and thanks for having me over. Um, so I'm Joel, and I'm a co-founder of 3 Bucks Labs. And today I'm kind of gonna give you an intro to ceramic and all of the technology that we're building, and yeah, and I'm also gonna give you um, something to play around with at the end. Cool. So I'll start by sharing the screen. All right. So ceramic um, is a decentralized network for version controlled data. And I'll get into what that means in a little bit. But I wanted to start with kind of giving you a history of 3 Bucks, and where we kind of came from, and why that led into the ceramic protocol. So um, 3 Bucks was started, I guess, between 2 and 3 years ago. And the first thing we created was an SDK called 3Bucks.js. And what this allowed you to do is kind of to store data that was associated with an Ethereum address. So at the time, the Ethereum kind of space was very focused on like all your backend stuff, like stateful things lives on chain on Ethereum, and we hadn't run into the scalability issues yet. And all the front end stuff is just like a static front end. And we saw like a huge need for more dynamic data that lived not, in the user's front in the smart contract on the blockchain, or used for a static web page. We needed some like more dynamic data on the front end that was not on the blockchain. So we created 3Bucks.js, which allowed you to store data and associate that data with an Ethereum address. And this is based on DIDs, or decentralized identifiers, which is like a W3C standard for just a way to associate and basically any cryptographic identity to public keys. And the first kind of use case of this was profiles. So once we could associate data with an Ethereum address, the first kind of thing that's annoying with an Ethereum address is that I can't see who that is. So we replaced the Ethereum address with like a name and an image. And that's essentially why we created this profile app called 3Bucks Hub. There you can see profiles of other Ethereum accounts, and you could also see kind of transaction history of that account. And we actually had one really kind of early NFT gallery that was focused on like your personal NFTs. But that wasn't really anything we were focused on. So that was just like a feature in the app. So that was that was kind of cool, and people started using 3Bucks for like chats and comments in their dApps. But eventually, like some parts of the 3Bucks system were centralized. So the way to associate like an Ethereum address to the DID was based on just a server that kept track of that mapping. So we kind of always wanted to like, yeah, we want to make that decentralized, but we were just trying to be pragmatic initially. But eventually 3Bucks grew, and like we knew that we were going to have to solve this problem. We started like thinking about, okay, how can we solve this problem and make the protocol more decentralized in general? Because 3Bucks, the actual data was mostly stored on the 3Bucks servers, even though other people could, in theory, like run nodes to back up 3Bucks data. So yeah, let's make a decentralized version of 3Bucks.js. What would that look like? And also, like, can we make it blockchain agnostic, so we can, associate Ethereum accounts to this data, but maybe also like, like Polkadot or Filecoin or what have you, like blockchains pointing to the same data. And we thought about that for a while and started like ideating, and eventually we came up with a protocol for like for this core piece of like linking identities, or like blockchain accounts to identities, and like updating the main kind of core identity documents. And that eventually led to like, hey, we can generalize this to something more broad. And that's essentially what ended up being Ceramic, which is kind of a network where you can create documents and have those documents represent some data. And those documents are like, you can kind of have those be version controlled. So you can look at old versions of that document. And IDX is short for identity index. And it's essentially like the next iteration of 3box.js that is kind of more general and allows developers to more easily create their own data sets and use that with their users. See, there's a message in the chat. I'm going to open it so I can say I'm disconnected. No. You guys hear me?
Yeah, we can hear you.
Okay, cool. Yeah, it's good. A little bit afraid there. Yeah, so you can look, you can kind of see IDX is like a decentralized user table where you store data with a user about a user with the user, so the user is actually like keeping the data with them as they go around to different applications. All right, so as I mentioned, Ceramic is protocol for version control data. So what does this mean? Well, the basic component of Ceramic is a document. So document is this object in Ceramic that you can update and change. So you can have information, you can update that. And each update you make to the document is verifiable, meaning that it's signed by the user's key. And updates are also periodically anchored into a blockchain, which gives us kind of like a proof of publication. We know that this document was actually published at this point in time. And that also gives us some nice properties, which allows us to do key replication and key rotation in a secure way in this network. And the cool thing about these kind of primitives, these documents, is that we can link documents to each other. So we can create kind of like a graph of documents which kind of all point to each other. It becomes kind of this dynamic information graph, which is like kind of difficult to censor if there's a bunch of nodes containing the same documents. Yeah, for the blockchain anchoring, documents are anchored into Ethereum by default. And this does not mean that every time you update a document, you need to make a transaction. Rather, every time you update a document, you can request an anchor from an anchoring service that takes a bunch of document updates from a bunch of users, creates a large Merkle tree, and just puts the root on chain. And then you can, for your document, you can just sync the Merkle witness or the Merkle proof for your specific document update. So you don't need to like care about the state of the entire network. And as I mentioned, documents are kind of signed and controlled by DIDs. We have a DID method called 3ID, which kind of is a very flexible DID method for associating multiple blockchain accounts and like doing key revocation in a good way. We also are working on an NFT, a DID method called NFT, which is basically kind of a fun thing where the current owner of the NFT is the one who currently controls that identity. So if there's a document that's owned and controlled by that DID, that document can only be updated by the current owner of the NFT. So this is kind of like a visual representation of how you can imagine the ceramic topology or the network looking like. So here you have like these circles representing nodes, and each node pins only the documents that they care about. So this node wouldn't need to like keep track of all the data for these other documents, which is kind of nice because then it's not like a blockchain where you need to keep track of all the data and it grows like forever. You only need to keep track of the amount of data that's like documents you pin. Yeah, and like when you want to get the updates for a document, you basically just ask the libpdp gossip network about like, hey, I have this document ID. What's the latest update for this document? The data structure of a ceramic document looks something like this. So at first, when you create the document, you create a Genesis commit, and then that can be anchored into a blockchain. So we have an anchor commit. There's like some proof metadata about like which blockchain was anchored in. Here's the blockchain transaction. And there's some more details here that happens like if there's like a large batch. So this proof metadata contains information about like which part of the batch like this commit was part of. But then if I want to update the document, I basically create a signature commit. And this contains a patch for the change of the content. So content is usually just like some JSON data. And the signature commit is just a signature over a JSON patch for like how to change the document. And then we see another signature commit to change again, another anchor commit. We anchor the document into the blockchain again. There's another signature commit to change the content again. So yeah, that's basically the data structure, like what makes this secure. And if there's a conflict here, there's a simple logic rule that's used that is basically the earliest anchor win. So if there's two anchors, the one that was anchored, or if there's two branches and they both have anchor commits, the branch that was anchored earlier will be the branch that wins. And each document is referred to by a document ID, and this document ID is generated from the Genesis commit. And essentially, you would just ask the gossip network, like, hey, what's the latest tip or like the latest commit for this document? And the gossip network would reply and say, like, hey, this is the one. And then you just like verify the chain of this document on your node. And yeah, you can each commit is kind of also like an immutable reference to that specific version of that document. Right, so we kind of got into kind of the technical weeds pretty quickly. So like at any point, if there's like any questions, feel free to like ask me or put them in the chat and I'll try to monitor that. So I'm going to talk briefly about some of the building blocks that we use to create ceramic. The first one is DAG Jose. So in IPFS, right now, IPFS is good for storing. Oh, and I should mention, like, all these updates and these commits, they're stored in IPFS or in IPLD, which more specifically is like the data format of IPFS. So you can think like ceramic is kind of like a layer on top of IPFS. So yeah, the question. Documents have owners. Yeah, documents have owners or controllers, which that's the only one that is allowed to change the document. So yeah, the DAG Jose is basically just a way to store signed and encrypted data in IPFS, which was kind of difficult before, but now we can kind of natively store IPFS data using an existing standard that existed from IETF. We've worked on standardizing something called DID provider, which is just a way to request signatures and request to decrypt data from a wallet. That's called EIP2844, and it kind of exposes the JSON RPC similar to like the Ethereum JSON RPC for this DID functionality that's used by Ceramic. And then the encryption, so Ceramic does support encryption. And for that, it uses XChaCha 20poly 1305, which is a cipher that's used in TLS. And it uses X25519 for key exchange. But using JWEs, you can really represent any type of encryption. This is just kind of the implementation that we care about because it seems like the most properly secure one. Then we have a library called JSDID, which is like a lower level library for interacting with DIDs, and it allows you to create these signed objects to decrypt data and do all of these things. So these are kind of the building blocks that allows us to make this data structure in a secure way. Uh, all right, so here's a bunch of stuff on encryption. I'm not going to dive like super deep into this um, uh, because it gets kind of into the weeds. But yeah, so ceramic in general, you can think of it as like a metadata layer for Web3. So um, we kind of allow you to create these documents, and these documents can refer to like any data on any blockchain, and it kind of lives in the peer-to-peer network, but it's not like really inside of any blockchain system. So it becomes this kind of middle ground for data to live in between blockchains. IDX, and I'm going to dive into this more after because it goes back into like why did we create ceramic when we were building 3box? So IDX is a standard for user-centric data sets essentially, and developers can create definitions, and each user gets their own record for each definition. And I'll dive into like how that works. Ceramic has a testnet that's running now that you can play around with, and you can find that at Ceramic Network and GitHub/ceramic. So that's kind of it for the ceramic stuff, and that went kind of quite deep technically. So I hope that was understandable. But let's talk about IDX. So 3box provided a way to associate data with a user account or like with an Ethereum account. IDX is essentially the same thing. However, it also allows you to associate with like an Ethereum account, but potentially other blockchain accounts, or like maybe like a layer 2 account on Ethereum. The cool thing about it is that you can actually take and like an Ethereum account and link that to your IDX, but you could also like have, if you have like a different account format on your layer 2, you could link that account to the same IDX. You can have like one identifier, even though you have like different types of accounts on layer 1 and layer 2, or potentially, yeah, also to like link it to the other blockchain. So identity index is kind of like a simple data structure that allow you to store data about users. So each user have their own index, and the index is a key value mapping from a definition to a record. And this kind of creates a semantic catalog for all of the users' information. So a record in this key value mapping or in the index is discrete unit of information about the user. So in a record, you could store content directly. So for example, you can store like a basic profile that contains like a name and an image for the user. Or you can store a reference to content that lives on some remote resource network. So you can like have a pointer that points to something that's stored on Filecoin or on OrbitDB, or maybe a centralized server somewhere, or in a registry on Ethereum. So like you can basically like point to resources in other places. The definitions describes the content of a record. So the definition contains a few different pieces of information. It contains like a schema that enforces the data within the record to have like a specific format. And it contains like a name that describes the record, and also might have like an additional like descriptions and URLs and additional configurations for the record. Yeah, so that's essentially it. So IDX is kind of really simple. You have the definitions that are created by developers that describe data, and then each user has their own index where there's a reference from a definition that is developer created to the record, which is each user has their own like record instance, right? So if you think about this from a developer perspective, like I could potentially start browsing different definitions that other developers have created and like start pulling that data into my application and like start composing these different pieces of data while I'm making my application. And IDX is a pretty simple API. I can use get information about a definition for a specific user or the AD. And if the user is authenticated, I can set the record content for a definition ID. And that's essentially it for what like IDX is. Finally, 380 Connect is a way to create a DAD for a user and associate that DAD to your blockchain account. So your Ethereum wallet, for example. So the way 380 Connect works is that you authenticate using your wallet like MetaMask, and then you're authenticated within this 380 Connect system that basically allows you to do these DID interactions. So let's see. So yeah. Well, yeah, and so the 380 did method is essentially an identifier that allows us to have like these multiple authentication methods. So I might have like MetaMask to authenticate to this DID method, and I might have like another wallet that I also use to authenticate. So I can kind of tie multiple authentication methods and like multiple, potentially like as I talked about before, like a layer 1, layer 2 block like account into the same identifier, so I can always kind of keep my account in one place. And the 380 DID method provides like a keychain that allows you to do like secure key rotation, which is very important if you want to have the ability to remove authentication methods that you have used and that you don't no longer want them to have access. Right. So the next thing I wanted to talk about is this IDX assignment. So it's pretty simple just to get you started with IDX, and like so IDX like a building on top of Ceramic and to store some user data. And it's an app that allows you to take private notes. So you authenticate as a user, you can create some notes, and those are encrypted privately to yourself. But you can also create a note and assign that note to another user. And now that note will be viewable by yourself and that other user, but no one else. So we can go into this repo. And this repo should contain all the information you need. Most of the things are already set up, but then like the instructions here for like how you install Ceramic and how you start using IDX and how you set up schema for so this is a schema for the definition, and that enforces like the data structure of the record for the user. And of course, like if you want to play around, you can start changing this and putting other stuff in here. And just for reference, the most interesting parts are probably not here. Probably in the app. And here we can see like a node is being created. And we can see like data is being encrypted. And we can see here when we load nodes, we try to decrypt all the nodes, put them back into the app. And this app uses 380 Connect and yeah, so it uses 380 Connect to kind of put data into IDX and interacts with Ceramic in the background. And yeah, there's a video walkthrough of this this demo as well. So if you want to have a look at that. And that goes through kind of in detail what this app is and how it works. So let's see. Yeah, I think that's it. So if you want to find out more information about Ceramic in general, you can go to developers.ceramic.network. And more information about IDX, we have a website, idx.xyz. And I see we actually have a bunch of time left. So I would love to kind of answer any questions you might have, or we could look closer at the application, whatever you kind of feel would be the most useful.
Yeah, um, any questions so far related to 3-box or ceramic? So Joel, yesterday we had a session with the IPFS team. They just covered the basics of IPFS. So could you practically, could you just how does it all relate, fit in together, like on top of IPFS, how does ceramic fit into the whole thing? Where could you explore, could you probably shed some light on some use cases where ceramic would be best?
Yeah, no, that's a really good question. So IPFS is great. It's like a network for like content, like static content delivery, right? Because you like put stuff into IPFS, you get a hash, and this hash you can use to like, okay, now I can always find that data, and regardless, I don't really care about where it comes from. I just know that the data has this hash, and I just think it's from some other peer. Like I don't really care which peer I think it's from, and that's really the power of IPFS, that kind of, you know, like deterministic lookup of data based on the hashes of the files. So as a primitive, IPFS is really cool. But if if you want something like mutable data, then you're kind of like, okay, if I change the object in IPFS, then I get a new hash. But everyone else is just going to have the old hash. Like that, how would they know that it has changed? And that's kind of the problem that we're trying to approach with ceramic, and we're also trying to deal with like, so the way, in order to solve that, like one way it could just be like to put something on chain, like on Ethereum, every time you make an update, but that becomes like prohibitively expensive to do so. And so with ceramic, we're actually just like creating the first object, then the next update to that object is just a patch on the data. So it says like how to change the data. And then it also includes the signature of the owner of the document, right? So we can see that, okay, this document is actually created and owned by this user. And now it was changed and updated by this user, the same user. And if someone else tries to sign an update, like make an update, that wouldn't be valid. So ceramic kind of becomes this mutable data structure that is kind of keeps evolving. So that I would say is like the main difference there. And like, of course, it's like built just on top of IPFS, but it also utilizes Ethereum to get a get this proof of publication property, which is basically like once a document has been anchored into the blockchain, we can know that this data, if I have this data, I can prove that this data existed at this point in time because I see that it's like has a pointer to it in the blockchain, and that gives us kind of this nice thing of that since we have those proofs of publications, we can more securely reason about if keys have been invalidated, then I know that if I invalidate a key at time A, right, and then at time P someone tries to use that same key again, like I could see like this key has been invalidated at this previous point in time, so you're not allowed to do that. But if you're like didn't have the blockchain anchoring property, then you would basically end up like, oh, the key was revoked, but this key now claims to sign something that happened in the past, and I can't prove that, that didn't happen after the key, or it didn't happen before the key was actually revoked. So that's like the reason we need to like anchor updates into blockchain, into Ethereum, is to get that kind of property of like proof of publication, and like get a I guess like a sense of progression of like what is going on and what has changed in the network. And I guess like in addition, so like we don't actually rely on the blockchain to find the latest updates. The blockchain is used like a way to keep track of what happened when. So in order to get the latest updates of one particular document, let's say, is that I know the genesis of like commit, and by that I know the document ID, and then I can just so I since it's built on top of Ethereum and IPFS, it uses libpdp. And libpdp I can just ask in like a gossip, like a pub sub topic, say like, hey, what's the latest update for this document? And then other nodes that pin that document keep track of updates for that document. They can reply with like, hey, this is the latest tip. This is the latest commit of this document. And now if one of those nodes were like fraudulent and sends me like an update that's like not correct, I would just like verify both of like try to verify both of those, like the real log and the invalid log, and now see like this log is actually invalid because it was like anchored later and it was using the wrong key and blah blah blah. So I can always like find the correct version of the document. Did that address all kind of aspects of your question?
Yeah, so was also yeah, there was another question also in the chat that says, does IDX require us to run an IPFS node?
So IDX requires an ceramic node, and a ceramic node is kind of an IPFS node and with some additional logic on top. So yeah, it kind of requires IPFS node, but it requires like actually a ceramic node. And if you look at this assignment, you can see that how to like start a local ceramic node and like how to connect to it. So that should be fairly straightforward, I guess.
Have you seen any, like, could you share some examples of projects or something that have used ceramic to their benefit?
Yeah, so obviously like with IDX, it's really any project that wants to display some information about a user or store some information with the user. So that might be like yeah, just like simple profile data, or more complex things like Bright ID verification or some other verification. So right now we're working with another project called SourceGrid to get some more verifications into IDX for, I think, GitHub, Discord, and Discourse. And what SourceGrid does is it looks at IDX and finds your Ethereum account and your account in these other platforms, and then it takes that data, and then it takes the data of like all the interactions of all the users on these platforms, and then it generates a score based on your contributions to a GitHub project and your contributions in like a Discord chat and on a Discourse forum, and then it calculates a score, and eventually it can like distribute a token based on that score. So they kind of use Ceramic and IDX as like a way to kind of associate one account with the different accounts that you have on these different platforms. So that's like some of the things you can do with IDX specifically. I think one of the other interesting applications that some people are working on right now is using Ceramic as like a commenting system in DAO governance platforms. So essentially, like right now in DAO governance, like people like discuss some topic that's being voted on chain in like a Telegram chat or somewhere else, but there's like no real kind of public discussion. And there's some platforms going in this direction, but with Ceramic, you can actually get this public discussion, and you can have like an auditable history of like what all the participants in the governance process said at what time and from that you kind of can add more trust into the governance process, more transparency. So that's like one I'm really excited about. Another thing in kind of governance is, well, you can build voting systems on top of Ceramic, and do some kind of off-chain signaling. So you can have like, since you kind of have the identities tied to on-chain identities, you could potentially do something like a coin weighted vote off-chain, and you can see kind of how everyone voted in off-chain, and then execute something on-chain. So that's something that we're looking at. Like, we're also like, I'm currently writing an article about how to do this with conviction voting. So conviction voting is like essentially a more fancy way of doing voting in like a crypto setting, where your vote becomes worth more the longer you kind of have staked your vote. So like the longer you commit to a vote without changing it to something else, the more value your vote gets, essentially. So there's, in voting is like, there's like a lot of interesting applications as well. I mentioned very briefly that we have this NFT DAD method, and this essentially allows us to the NFT DAD method is a system that allows you to have an identity that's controlled by whoever is the owner of the NFT. So using that, you could create a document in Ceramic where the only one that's allowed to update that document is the owner of the NFT. So you can have like NFTs that are kind of like guest books, or like art that only the owner can contribute to, or something like that. So that's kind of exciting as well. Yeah, I think that's just a selection of some stuff.
Right. How does Ceramic relate with textile?
So yeah, so textile is well, I guess they're really focused on like creating a very efficient like database using IPLD and IPLD and like the IPFS primitives, and they're really focused on like being close to the Filecoin kind of ecosystem. So we see them as like very synergistic with Ceramic, where you might have, we're actually working with them to start supporting the IDs and like the identifiers that we have in Ceramic. So you could use Textile as like a data storage system, where you store, like, you make a lot of data changes, and then in your IDX you store a record that points to like, hey, this is the Textile thread where all my data lives. So you can use Textile as like these kind of databases, and then IDX is like a point of reference where you can like have different sets of data that lives in like different Textile databases, if that makes sense.
I don't know. So do you have any sort of like quick assignment or something that they can do to just understand the basics behind Ceramic?
Yeah, so this was the thing that I showed a little bit, and I'm gonna send the link here in the chat. So this will get you kind of the basics of, most of this app is kind of already set up, but it will get you the basic of like how I create an IDX definition, and how how to use that in an application. I see there's another question in the chat. The Ceramic has an SDK for other languages than JavaScript/TypeScript. So Ceramic has an HTTP API that you can use to like read data. You can also use it to write data. However, if you're writing data, you need to have produced a signature client side. So if you have a way of producing like JSON web tokens client side using some DAD method, then you could use Ceramic through the HTTP API with any language that you prefer. But right now we have like the clients and the SDKs for Ceramic are mainly only TypeScript.
Are there any implementations where you can store the history of a Ceramic document across chains? For example, my first commit is, let's say, on Ethereum, and the second commit is on Polkadot. Is that even possible in any way, or has there been any implementations for cross-chain?
Yeah, I mean, it's definitely possible. And right now we are running on the Clay testnet. We're running an anchor service on Ropsten. I would say like, yeah, you can do that, but I would say that anchoring it like on different chains like doesn't provide like too much more value, I think. Like what's the kind of use case you're imagining there? Because like why would it be beneficial for you to kind of anchor one thing on Ethereum and one thing on Polkadot? Like it's doable for sure.
Somewhat like, let's say if I'm trying to update a document and then the gas fee is too high on it, and I need to commit to it immediately. Can I rather put it on a different blockchain? I can do the anchor commit on a different blockchain, and it still maintains the history on the Ceramic network, and I save money. It's basically wherever I'm getting the lowest gas fee at that point of time, or let's say I have some other benefit that I'm getting on that chain.
Yeah, so that's definitely possible. Like, but I would say like in many cases, I'm gonna actually show you a visual here. That wouldn't really be needed. So like you're not actually, for every document that you change and update, you're not actually making one transaction per document that you change. Instead, like you probably are just interacting with some anchor service that takes a bunch of updates from a bunch of different documents. It creates one big batch that it anchors on chain. And I'll see here if I can find the visual for like how this works.
Transaction costs.
So right now, initially on the mainnet of Ceramic, which we hope to launch soon, we will run an anchor service and anchor and pay for those costs initially. But we imagine that there will be like multiple anchor services that have like different settings and like different configurations of like how frequently it anchors. But in it's likely going to be like that. You have some relationship with that service as like an application developer. In like the longer term, we're looking to create like an incentivized network where you can actually use like pay the network to keep documents pinned and stuff like that. So yeah, so this is like what this data structure looks right now. So when let's see, so actually the visual, yeah. So when an anchor service gets a bunch of documents that it wants to anchor, then it basically creates this tree here. And so like for all of these leaves here that we can see, there's like an update for a specific document. And then the specific anchor record just contains like one of the paths here in this Merkle tree. All right, so that was what I wanted to show. But yeah, so right now in Ceramic, you kind of need to either you have a node yourself where you pin the documents, or you basically trust some other entity or like some other organization to run a node that pins your documents. Eventually, there's going to be an incentive in the Ceramic network where you can pay the network to just pin the documents and keep track of them, and that will also like kind of include the potential fees for like the anchoring itself. If that makes sense.
Yeah, but when you say that the request will go to the Ceramic network, would it go to a specific set of anchors, or would it be gossiped on to the complete network itself?
Well, so right now,
for any anchor.
Yeah, so right now you make an anchor request to a specific anchor service. And that's something you can configure, like which anchor service you want to use. In the future, that would be like going directly to the main node.
Okay.
So there's another question in the chat. It says, is the Ceramic HTTP API decentralized? So HTTP APIs by definition are hosted by some service because it's an HTTP. The HTTP protocol is like you ask some server about something. I guess you could like, you know, anyone could run a Ceramic node that exposes this HTTP API. So in that sense, it's decentralized because like I could make the request to node A or to node B, and I should get the same result, right? But the HTTP API in itself is, you know, because HTTP is centralized, it's centralized, but you can run that on any node. That makes sense. All right, cool. Well, there's no other questions.
Yep.
Well, thank you so much for the chance to chat to you all.
Yeah, thanks a lot, Joel, for joining us, and sure, they'll like going through the assignment too. So
yeah, and let me also just like send you an invite to our Discord in case you want to get in touch with us. Give me 1 second. There you go. So yeah, we have a Discord for Ceramic, and there you can come on and like ask any questions to run into issues or something.
thanks a lot, Joel. Thanks.
Cool. Yeah, thanks.
Yeah, thanks for making the time.
See you on the internet.
Yeah. Bye-bye. All right, folks. I think, yeah, so that's Ceramic. That's the next layer over IPFS. Yeah, so just check out the assignment, the video walkthrough. There's also a video walkthrough. So maybe just go through that and let us know. If you're stuck at any point, you can always reach out on the Discord. Yeah. Right, I think we can call it a day.
Denver, could you like share a tentative schedule of like how this week will go? Like, do we have a session every day?
Yeah. So there's the next session that I finalized so far is